Hello, and welcome to the Sage X3 product demonstration. I'm Dave Cranage, Field Sales Engineer for Sage X3. Today's demo will specifically focus on the capabilities of Sage X3's dynamic finite capacity-based scheduling engine, web scheduling. During the demo, we will cover an introduction to web scheduling and its core capabilities, how to use the scheduling console to visualize the schedule, how to use the automated scheduling engine to generate a production schedule, how to manually manipulate that production schedule. We'll review available reports and analysis tools, and finally, how to release the production schedule back to X3. That's a full agenda, so let's get started. Web scheduling is a user-friendly, cloud-enabled, finite capacity-based scheduling engine that prioritizes work orders to meet specified delivery terms, optimizes work centers based on a company's optimization goals to group work orders and reduce changeover time, synchronizes work order operations based on upstream and downstream constraints while respecting material and resource availability, and it allows schedulers to manually manipulate or fine-tune the generated production plan, bringing the results completely into focus. Web scheduling is completely integrated with Sage X3, syncing information such as work centers, optimization goals, product BOM and routing, material availability, and work order details to generate a resulting production plan and release it back to X3 for use by production. Web scheduling provides support for multiple simultaneous schedulers working in parallel on multiple product lines or production sites. Web scheduling also provides a unique scheduling console for schedulers to interact with the production plan in the most effective way for them. Web scheduling uses an automated scheduling engine that generates a production plan that is 90 to 95% accurate, which can then be manually edited to bring the plan into focus, giving the scheduler the best of both worlds, automation and control. As the plan is manipulated, web scheduling provides real-time status notifications in order to verify the global effects of the changes. Finally, the scheduler can utilize simulations or what-if scenarios to create an unlimited number of variations of the production plan and analyze that to determine the most effective schedule. Let's start off our demo by taking a closer look at simulations. An active scheduling session always has at least one simulation. The current active simulation is shown with a check, and the master version, to be synced with X3, is called out at the top of the simulation. If the user has multiple simulations, they can decide to make a new master version, and this becomes the version of the schedule to be synced with X3. Simulations can be viewed as tiles with statistics and KPIs, or simulations can be viewed in a grid showing some basic KPIs. There is also an option to see a side-by-side comparison, making what-if analysis simple and easy. Let's create a new simulation to use during the remainder of our demonstration that will allow us to do a comparison of the two simulations at the end. To do this, let's click on the master version and select the copy simulation. Give it a name, give it a description, and hit save. Now let's drill into our new simulation and take a closer look at web scheduling's capabilities. Now I realize we're looking at a brand new screen, what I like to call the scheduler's console. So let's take a minute to get comfortable with what we're looking at. Taking up a good portion of the upper screen is the primary scheduling tool called the production Gantt. At the bottom of the screen are three supplemental tools supporting the production Gantt: the fishing pond, resource Gantt, and order Gantt. Finally, we can access the automatic scheduling manager commands toolbar by hovering over the three dots or the ellipses. The production Gantt, the fishing pond, resource Gantt, order Gantt, and the scheduling manager commands toolbar represent the tools we'll use in creating this simulation's production plan. Let's look at each in detail. The production Gantt provides the scheduler with help visualizing their resources and how they are used by work orders and operations or phases across time. Let's make the production Gantt a little larger so we can see better. I'll use the Expand Contract tool in the center of the screen to expand it to full view. There is also an Expand Contract tool on the left side of the screen. Let's adjust that as well. If needed, you can maximize the production Gantt to full view. Starting on the left with the resource tree, let's expand it to show the work group or site and its resources. Scrolling to the bottom of the tree, we see a group called Assembly. Clicking the group emphasizes the Work Center resources on the production Gantt. Selecting a specific Work Center within the group isolates that resource on the production Gantt. This gives the scheduler control over what they see in the Gantt chart at any given time. Scrolling back to the top and clicking on Production System refreshes the full resource view in the production Gantt. Collapse the resource tree to hide the resources. Now that we know the resource tree is there if we need it, let's hide it by clicking on the Expand Contract tool on the left to get a full view of the Gantt chart. I don't see any work orders on the Gantt chart, so I'm going to apply a custom filter to show only the stool Work Center resources. Custom filters allow schedulers to view and work across different resource groups at the same time, sequencing the resources to their personal preference. With the filter applied, we see only the stool Work Center resources and their associated work orders. Notice the resource tiles on the left show a pencil icon. This indicates the resource is locked. We also see the site, Work Center ID, and description on the tile. This information comes from the Work Center details. The par machine value is the web scheduling equivalent to the number of resources field in the X3 Work Center. It represents the number of available duplicate resources and contributes to the calculation of that Work Center's total finite capacity. But what about the infinity symbol shown on Work Center LAB 101? What does that mean? Great question. The infinity symbol is web scheduling's way of illustrating that the Work Center has infinite capacity. We define this resource as having infinite capacity in the X3 Work Center. Focusing more closely on the Gantt chart, the white space shown on the resources is web scheduling's way of illustrating the resource's available capacity. The blue space illustrates where the resource is unavailable or shut down. Several of the work order phases on the Gantt chart extend across these blue areas or unavailable periods. Those phases aren't using the unavailable period. It's the way web scheduling illustrates that a phase started in a shift before it ended and will be carried over that unavailable period to the next available shift. At the top of the Gantt chart are the month, day, and time. A Gantt chart is the best way to see many interrelated activities across a designated period of time. In web scheduling, the defined period the scheduling engine calculates into the future is called the scheduling horizon and is defined by each organization to meet the needs of their production environment. Adjusting our gaze up, we see the Gantt toolbar and the calendar icon. The calendar icon gives the scheduler control over the range or portion of the scheduling horizon they want to view throughout the editing session. The plus and minus icons allow the scheduler to fine-tune how that range is visually represented on the Gantt. Web scheduling can also respect a defined frozen period, or a period where all scheduled work orders and tags or phases are locked. When enabled, this frozen period is defined as a range from the start of the schedule out in time to an end date. The production Gantt also comes with scenarios, various visual representations of the production plan that highlight important information for the scheduler with conditional coloring. By dynamically using logic to color Gantt chart tags or phases, conditional coloring highlights critical planning details specific to a resource. Users trained to use the web scheduling configuration tools can configure custom scenarios to analyze the production plan from different perspectives. Out of the box, web scheduling includes 5 conditional coloring scenarios. The default, which is a plain view of work orders and their phases, which is typically used to copy and edit new scenarios. Priority sequence, which shows work orders that have been set in a specific priority on a resource. Missing material, which shows work order phases with missing material. Forced date, which shows work order phases with manually forced moves made by the scheduler, and advanced delay, which shows whether work orders and phases are on time or delayed. Let's look at the advanced delay scenario to better understand the impact of conditional coloring on the production Gantt. Right away, we see multiple colors communicating information to the scheduler, including red, showing work orders with a due date equal to or earlier than the current planning start date. These work orders are late. Orange, showing work orders with a scheduled end date later than its due date by more than 10 days. These work orders are late but may be salvageable. Yellow, showing work orders with a scheduled end date later than its due date by less than 10 days. These work orders are late but are salvageable. Green, showing work orders with a scheduled end date equal to or earlier than its due date by less than 10 days. These work orders are on time. And dark green, showing work orders with a scheduled end date earlier than its due date by more than 10 days. These work orders are early. Conditional coloring effectively communicates critical work order and phase information to the scheduler in real time directly from the production Gantt. As we've seen, the production Gantt conveys important information for each work order and its phases. Zooming in, we see that each work order phase tile shows graphical icons and textual details of the work order, but zooming in and out all the time is inconvenient. Instead, hover the mouse pointer over a work order phase tile and, no matter how small, it will immediately show the sought-after information via the Gantt spy. Double-clicking on a work order's phase brings up its activity detail screen. Here, the Work Order Details tab shows work order information and alternate resources capable of running that work order's phase. The Activity Manager tab allows you to review and edit key operational information, such as start and end date time, quantity, work time, and notes. Adjustments to these fields are considered manual changes to the phase and are immediately reflected when you return to the production Gantt. Click on a work order phase on the production Gantt to highlight its related phases. The arrows that appear indicate the upstream and downstream material dependencies between the phases. This synchronization is an important aspect of web scheduling and guarantees that all work order phases are in proper sequence and being worked on only when the required resources and materials are available. A resource's finite capacity dictates how much time is available to produce work on any given day. When that day's capacity has been reached, work on that resource overflows to the next day. This continues until all work is scheduled or the end of the scheduling horizon is reached. Combine that with material availability constraints that a resource can do work only when all necessary material components are available, and synchronizing a work order's activities can get more complex than a typical human brain can handle. Using the concept known as first date of material availability, or FDMA, web scheduling dynamically respects a resource's finite capacity while also managing the availability of a work order's required material components. FDMA is the date calculated for each material component of a work order when component availability can cover in full the required quantity scheduled to be produced on the work order. Web scheduling's algorithm utilizes FDMA and finite capacity to optimize the production plan and deliver a result in which these two key constraints are in sync. Web scheduling's algorithm goes further to group and optimize work orders with similar attributes on a resource to reduce changeover time. The system uses the X3 product attributes and optimization parameters to group work orders and reduce changeover in real time on the production Gantt. That is what we're seeing here. Based on the leg colors, we are seeing group products and their calculated changeover time. Reducing changeover returns time to the resource and increases available capacity. The result is improved throughput and on-time delivery. We'll come back to optimization a bit later when we discuss manual manipulation of the schedule. For now, let's change our focus to the supplemental tools supporting the production Gantt, the fishing pond, resource Gantt, and order Gantt. A couple quick points on the three supplemental scheduling tools. First, they are linked to and provide complementary capabilities that enhance the functionality of the production Gantt. Second, they stay synchronized with the production Gantt work order visualization as the scheduler selects different phases within the tools. And then finally, each tool is personalized to the scheduler's personal preferences with different visual scenarios, custom columns and sequences, groupings, sortings and filters, and unique decoration rules. Let's start with the fishing pond and move our way through the three tools. The fishing pond is the scheduler's to-do list. It shows all work orders and phases for the locked resources. These work orders and phases can be automatically or manually scheduled from the fishing pond. This provides flexibility the scheduler needs to interact with the scheduling engine. The fishing pond is an easy way to see all work order phase details and can be filtered by columns to get specific subsets of data a scheduler may need. By double-clicking on a work order phase in the fishing pond, the scheduler can access further phase details showing additional work order phase information. Conditional formatting, called decoration rules, can be applied to the phase values shown in the fishing pond. Scrolling down the attribute column, we see that the intermediate work orders for the different colored stool legs shows the color attribute font in the actual leg color, black, red, pink, etc., with a gray background. This is a decoration rule. Decoration rules provide pertinent real-time graphical information to the scheduler and may be applied to any of the columns in the fishing pond. Like the production Gantt, the fishing pond may also have scenarios to organize and manage anything the scheduler would like to see in the fishing pond, including specific warnings and inconsistencies in the schedule. All this data may be filtered and exported to PDF or Microsoft Excel. Let's continue looking at the supplemental scheduling tools and move to the resource Gantt. The resource Gantt displays line by line sequence productions and downtimes for any resource selected in the production Gantt. This helps the scheduler understand usage of available resources. Within the resource Gantt, the scheduler can take advantage of the capacity trend to analyze the sum of the parallel machines currently in use and what machines are still available. The capacity trend uses color coding at the resource level to communicate the availability of each capacity-constrained resource. These colors are tan, which represents the total number of parallel machines available, purple, which represents the number of required parallel machines and is lower than the available amount, green, which represents the number of required parallel machines and is equal to the available amount, or red, which represents the number of required parallel machines and is higher than the available amount. For infinite capacity resources, the resource Gantt does not show the capacity trend. Instead, it displays a chart of the required resources. In the resource Gantt, the scheduler may insert periods of downtime, which are blocks of time when a resource is not available due to some sort of issue. This impacts the selected resource's available finite capacity. Let's add a downtime, give it a start date, and give it an end date, and hit OK. We now see a tag on the resource and production Gantt charts showing the downtime. Double-clicking the tag allows us to enter a reason code and description for the downtime. Finally, in the resource Gantt, the scheduler can manually manipulate multi-resource and infinite capacity work centers and fine-tune their schedule. Before we get into manually adjusting the schedule, let's jump over to the order Gantt and check out a work orders PERT diagram schedule view. The order Gantt is a read-only interactive report that shows all work orders loaded into the active simulation. Each order can be expanded to show all its phases in sequence and across time. Let's scroll down and find a work order for our standard stool legs to look at. As you can see, the order Gantt is a combination of a work order chart showing the length of time a work order is in production with a PERT diagram view or flow of the work order's phases sequenced across time, all on one screen, giving the scheduler the best of both tools. Now that we understand our primary and secondary scheduling tools, let's move on and investigate web scheduling's automated scheduling capability. Since we've made some changes along the way, let's use our auto schedule to apply them. To do this, let's go to the scheduling toolbar and select the Run menu option, Run, to kick off auto scheduling. Web scheduling's automated scheduling algorithm uses a forward-based scheduling technique as well as the ASAP scheduling method to dynamically prioritize, optimize, and synchronize the active simulation. The result is the most efficient production plan possible. And as you just saw, it does this in seconds, while most manual scheduling methods would take several minutes, if not hours. To do this, web scheduling uses heuristics, or rules and settings, to define how the scheduling engine should operate. Let's go back to the scheduling toolbar and select the Run menu option, Settings, to look at a few of these key heuristics. As you can see, web scheduling allows the scheduler to create different variations of their scheduling settings. Here I've created a sample setting called My Default. Why have multiple versions of the settings? Again, great question. It's so that schedulers can adjust the heuristics used within each simulation, giving them complete control over the results of their what-if scenarios. Drilling into My Default, we can see multiple tabs across the top. Let's go no further than the first tab. Here, we see two critical settings or rules that impact how web scheduling optimizes and synchronizes the resulting production plan. The setup times setting tells web scheduling to use the optimization matrix to determine setup or changeover time. This also enables the element of the algorithm that groups like work orders and minimizes the calculated changeover time. The work order's launch date setting defines what date will determine when the work order can be scheduled to start on a resource. This setting tells the algorithm to utilize the FDMA date as part of the constraint checking and synchronization process. Combine these with the ASAP scheduling rule, considered the best method to meet a specific requirement date when prioritizing the schedule, and have a powerful set of rules to drive the decision-making of web scheduling. There are more settings, but that gives you an idea of how web scheduling settings can be used to drive its automated scheduling algorithm. Let's head back to the production Gantt and run auto scheduling again. Not to belabor the point, that was seconds, not minutes, to get a fully optimized, prioritized, and synchronized production plan. The most valuable result of the automation is the amount of time it gives back to the scheduler to review the new production plan, make any final manual adjustments or fine-tunings, and then compare it to other simulations. Before we do any comparisons, however, let's look at some of the manual adjustments a scheduler can make to the production plan. To review what manual adjustments a scheduler can make, let's go back to the production Gantt and adjust our view. And we'll do this by using the production Gantt filter for the Paint robot resources. We'll also change our view period to start on a more specific date using the calendar tool. And finally, we'll filter the fishing pond by the attribute mint. We now have the fishing pond filtered to focus on the first tag or phase on Paint Robot 1, Mint Standard Stool Legs. Let's play a bit with that phase. First, let's click and drag the Mint phase onto robot number 2 and move it out a couple days into the future, dropping it somewhere in the early afternoon. Then we'll manually force or fix it to robot number 2. In doing that, notice the phase went from having no changeover time to having a bit of changeover time. This is because the previous work order was white. Also, the phase went from being 4 hours on robot 1 to 3 hours on robot 2. This is because of the difference in percent efficiency between the two paint robots. And finally, you probably noticed that paint robot number 2 highlighted a darker blue. This is because the paint robots are alternate resources for each other. Let's rerun auto scheduling. Notice that web scheduling kept the phase on paint robot number 2, but moved it back into the first position. This is because I only fixed the phase to the new resource. Let's double click on the phase to get to the activity details and activity manager. Let's edit the phase start, date, and time, and hit OK. This is another way we can manually manipulate the phase. You don't always have to drag and drop. This time, let's set the phase fixed launch date, or pin it, to the resource at the specific date and time, and then rerun scheduling. Web scheduling kept it on the resource and at the date and time we assigned it to. Our last manual move will be to tell web scheduling that we want to maintain the sequence of work order phases we've just established. We do this by selecting the last phase in our group and manually selecting the Set Priority Sequence option. This locks the sequence and maintains the phases in that order until the scheduler decides to remove the prioritization. Notice that the sequence goes from 60 backward to 10. Manual adjustments trigger real-time status notifications that alert the scheduler of warnings or inconsistencies generated by those changes. Looking at the phases we've been working with, we see several icons and numbers. But what other icons might we see on a phase? Clicking on the Information Toolbar option, we get a legend of icon decorations and descriptions. Scrolling down to the bottom, we see the chain link icon representing a warning for fixed resources. We saw this on our phase as well. These icons show up on the production Gantt work order phases, but they also show up in the supplemental scheduling tools like the fishing pond. Let's revert to our original view of the production Gantt by setting the filter to the US Stool work centers and setting our calendar back to a wider view beginning on today. Finally, we'll save our modifications to the simulation. Back on the simulation page, we can control-click the two simulations and select the comparison option to view them side by side. Within the comparison, I can move through the KPIs, evaluating the differences between the two selected simulations. Once I've done my analysis, I can choose to continue making new simulations building on my efforts, or I can make the latest simulation the master simulation and submit that back to X3 as the latest production plan. Once the schedule is released, it is accessible company-wide and can be viewed from other web scheduling sessions or directly within Sage X3. This level of access improves communication and awareness and eliminates the disconnected and time-consuming manual scheduling processes. So, after that overview, I'm sure you're convinced that web scheduling is a great production scheduling solution for your company. Let's quickly summarize what we covered. We started with an introduction to web scheduling and its core capabilities. We then discussed how to use the scheduling console to visualize and work with the schedule. We utilized the automated scheduling engine to generate new production plans, manually manipulated the production plans we generated, reviewed some of the available simulation analysis tools, and finally discussed how to release the master production schedule back to X3. It is clear that dynamic, automated, finite capacity-based scheduling systems like web scheduling help companies not only better manage inventory availability, increase resource capacity, improve production throughput, and increase on-time delivery, but they also help companies become more efficient and cost-effective, directly and positively impacting their bottom line. Thanks for taking the time to watch this overview demo, and keep an eye out for more great product demo videos from Sage.